This is a map of California where the green line runs through the state from the Salton Sea in the south northward for approximately 800 miles through both coastal and inland regions, revealing the location of the San Andreas Fault. The fault is notorious for dividing California in half and causing deadly earthquakes that keep the U.S. government and Californians on the edge of their seats. It is always closely monitored, but recent discoveries indicate that something even more catastrophic is on the horizon. The question is, when will the San Andreas Fault finally give way? Will it cause California to slip into the sea? The anticipation of such a significant event is palpable, and scientists are racing against time to find answers before it's too late. Join us as we delve into the ominous signs that the San Andreas Fault is about to crack and what that could mean for California and the world. The San Andreas Fault is a name that immediately triggers thoughts of catastrophic earthquakes, especially for those living in California. It is a major crack in the Earth's surface found in the far western part of North America. This fault stretches for over 800 miles, running northwestward from the northern end of the Gulf of California through the western part of California and then reaching the Pacific Ocean in the region of San Francisco. What makes this fault so feared is the constant tectonic movement detected around its base, often leading to earthquakes along its path. A tragic example that still resonates with Americans is the destructive earthquake that struck in 1906. Although a smaller earthquake happened in 1989, 5 years later, the suburbs of Los Angeles experienced a more powerful and damaging earthquake along one of San Andreas' larger secondary faults. Despite the devastation caused by these events, it's important to note that the fault line itself did not move directly through the affected towns. However, several communities lie squarely on the fault line and are vulnerable to a potential earthquake disaster. Point Reyes Station, Fraser Park, Daly City, Desert Hot Springs, Gorman, San Bernardino, Wrightwood, Palmdale, and Bodega Bay are all sitting ducks. The recent announcement by Thomas Jordan, the director of the Southern California Earthquake Center, about the critical state of the San Andreas Fault has turned the minds of every Californian and made them anxious. According to Thomas, the fault line is in a critical state and a massive earthquake could be looming underneath. Californian residents are already living with the fear that the fault line could unleash at any moment, but this new warning has made them even more scared. The Southern California section of the fault line is particularly vulnerable, and Thomas commented that it looks like it's locked, loaded, and ready to go. The last time this region suffered such a disaster was in 1857, when a magnitude 7.9 earthquake ruptured a breathtaking 185 miles between Monterey County and the San Gabriel Mountains near Los Angeles. It has been too quiet for too long, and the springs on the San Andreas system have been wound very tight. The recent announcement made during the National Earthquake Conference in Long Beach has put everyone on high alert, and they are now wondering when the next earthquake will hit and how devastating it will be. The San Andreas Fault has long been a source of anxiety for Californians, and for good reason. It is a major tectonic boundary where the Pacific Plate is slowly moving northwest relative to the North American Plate. This movement should relieve about 16 feet of accumulated plate movement every 100 years, but unfortunately the stress has been building up for over a century. The director of the Southern California Earthquake Center, Thomas Jordan, recently sounded the alarm that the fault seems to be in a critical state and a great earthquake could be looming underneath. However, this section of the San Andreas Fault is not the only one overdue for an earthquake. San Bernardino County around the southeast in the Cajun Pass has not significantly moved since an earthquake in 1812. Meanwhile, areas southeast towards the Salton Sea have been quiet from about 1680 to 1690. To compound the problem, geologists have studied the movement of tectonic plates and discovered that the Pacific Plate is moving northwest of the North American Plate. Jordan advises the California government to focus on preparing for a potentially powerful earthquake, one as tough as a magnitude 8. He praised Los Angeles for taking proactive measures to mitigate their vulnerability to earthquakes by incorporating earthquake retrofits on apartment and concrete buildings. It is critical for other communities like those in San Bernardino County to follow suit and take the necessary steps to become vital in the face of an impending earthquake. Mayor Eric Garcetti of Los Angeles has been working tirelessly to ensure that the city is prepared for the worst-case scenario when it comes to earthquakes. His efforts to incorporate earthquake retrofits on apartment and concrete buildings have been applauded by Thomas Jordan, director of the Southern California Earthquake Center. Jordan expressed his surprise at the success of this plan and said it's remarkable that this happened, We know politically how difficult it is to make these changes. However, despite these efforts, California still finds itself ill-prepared for what is to come, with the San Andreas Fault finally giving way. The state is facing one of the most devastating natural disasters it has ever seen. According to a report from the U.S. Geological Survey, a magnitude 7.8 earthquake on the southern San Andreas Fault could cause 50,000 injuries, $200 billion in damage, and severe long-lasting disruptions. This sort of powerful earthquake could last for almost 2 minutes, with the strongest shaking happening in areas like the Coachella Valley, Inland Empire, and Antelope Valley. It could also result in pockets of strong shaking in areas where sediments trap shaking waves, such as the San Gabriel Valley and East Los Angeles. To make matters worse, the sewer system could be out of commission for up to 6 months, and an estimated 1,500 deaths could occur. This is a grave situation that requires urgent action to prepare for the worst-case scenario. Other areas being focused on include strengthening Los Angeles' unsafe aqueduct systems and telecommunications networks. It is essential for California to act fast to mitigate the potential damage and loss of life caused by a disaster of this magnitude. The San Andreas Fault has the potential to cause catastrophic devastation, which can be understood by looking back at the 1857 earthquake, also known as the Fort Tejon quake. This earthquake, estimated to be 7.9 magnitude, was so powerful that it earned its name, despite starting farther north in Monterey County and moving southward through Fort Tejon to the Cajun Pass in San Bernardino County. The shaking lasted 1 to 3 minutes, causing soil liquefaction and uprooting trees in places as far as Stockton. However, even though the San Andreas Fault runs directly into Los Angeles, it is located 30 miles away from the downtown area. Unfortunately, this distance doesn't mean that the city is out of danger. In fact, the city is expected to experience severe shaking if a large earthquake occurs on the fault due to its proximity to the San Andreas Fault system. To help people understand the extent of the possible damage, Thomas Jordan and his team simulated a magnitude 7.8 quake on the fault. The simulation starts from the Salton Sea and moves west toward the San Gabriel Mountains, showing how seismic waves can affect the Los Angeles area. Additionally, another simulation video shows the ground shaking stretching from northern San Diego County to Barstow. In 2010, the Southern California Earthquake Center used a supercomputer to create a simulation of what a magnitude 8 earthquake on the San Andreas Fault would look like. The simulation was designed to be similar to the powerful 1857 earthquake, but even stronger. It begins in Monterey County and moves further south towards the Mexican border, with the LA Basin and San Fernando Valley hit hard due to the trapping of shaking in soft soils. You can see that this area of influence by the shaking has expanded to huge proportions, says Jordan. The directivity pulse shoves energy down the fault and excites sedimentary basins like the San Fernando Valley, Los Angeles Basin, and San Bernardino. The shaking in the Los Angeles region would persist for long periods if the simulation were to happen. What type of fault would we call the San Andreas Fault? According to the theory of plate tectonics, the San Andreas Fault is the boundary between two major plates of the Earth's crust, the Northern Pacific to the south and west and the North American to the north and east. The Northern Pacific Plate is moving laterally past the North American Plate in a northerly direction, making the San Andreas Fault a strike-slip fault. Though the plate movement relative to each other has been about 1 centimeter per year of geologic time, the annual activity rate has been 4 to 6 centimeters per year since the early 20th century. With such activity, it's only a matter of time before the next big one. The San Andreas Fault is notorious for its role in causing devastating earthquakes, with some sections of the fault moving as much as 6.4 meters during the 1906 quake. Despite this, some still refer to the San Andreas as a transform fault, but understanding what this means can be a bit tricky. Think of 2 slices of pizza on a table, with one slice of pepperoni and the other with anchovies. As you slide them past each other, bits of pepperoni crumble and drop onto the anchovy side. This is exactly what happens with the fault, making the geology and landforms along the massive rift incredibly complex and unpredictable. It's important to note that despite the danger it poses, the movement of the tectonic plates is actually quite slow, with an average speed of just a couple of inches per year, about the same rate at which your fingernails grow. However, this motion is not steady, and there are times when the plates become locked, pushing against each other without moving at all. When this happens, the average motion can be just a couple of inches per year. However, when the strain finally builds, Up enough to overcome the friction holding the plates together, it releases all at once in the form of an earthquake.